We keep talking about multivariate function in calculus. Multivariate means multiple variable in calculus. So, if we see the analogy of equation, so if I have a variable x that is independent variable, and based upon x there is a function called fx. So whatever is the fx, that is dependent upon the x. So that is dependent and independent. So independent is x and dependent is fx. So generally we keep fx as orthogonal. If it is orthogonal and x is I direction, then fx is j direction, that is y direction. So generally we say y equal to fx. So if x varies, then y also varies. So x is not dependent upon y, but y is dependent upon x. So with variation in x axis, how much x varies? So with each x, there is y. How much? If there is one unit variation in x, then how many unit of variation in y? That is dy by dx. That is differentiable. So a function fx is differentiable means we have definite dy by dx, and dy by dx can be a constant, or like there is a function called x. So when x is growing, y is also growing. So there is a curved line. So there is a curved line. This is x-axis, there is a curved line, 45 degree. Now if I differentiate dy by dx, it will come to 1. So as x is varying, if x varies 1 unit, then y also varies 1 unit. So that is the science. Now in multivariable function, we have two independent variables. So we consider like if I have x and y, then dependent variable is fxy. We had fx, x and fx, that become y upon x. Now I have z upon x and y. So fxy and z. So z equal to fxy. If I calculate z, dz by dx, means fxy, I have to differentiate with the x, keeping y as constant. And dz by dy, then I have to calculate differentiation of fxy, where I have to keep the x constant. Now I have a guitar in hand. Okay, so this is not, I believe thread is visible. So this is a rubber thread, and these are 2 points, and I believe it is more visible. Now, okay, now this is x, okay, and suppose this is y, this is x, and this is y, or if this is x, then vertical is y. Now I am pulling this thread. Now x is varying. I mean, y is varying. X is in this direction, and y is constant. Now I am pulling it. Y is varying depend upon the x. So now y is not constant with the x. So at the beginning phase, when x is growing, y is also growing. After some time, when x is growing, y is decreasing. Now I leave it. There is vibration. I mean, it should be visible. It is visible. There is vibration. Okay. So this this is this is a guitar thread, and in guitar thread, if I have a string and I pull the string and leave it, then there is a vibration. Now, what is y? So y is, if I pull it, okay, and leave it, okay. So y is changing, okay. X is changing in I direction, y is changing in j direction. So if I pull it, then y is maximum when x is half the way, and Before half the way, y is growing. After x half the way, y is decreasing. So this is a singular function. Means there is only one independent variable and there is one dependent variable. So y depend upon x. So if I pull it, then y grows when x grows, and when after some time when x grows, y decreases. So this is the equation of y. I mean, is it really single variable? Okay, so that is the question. Now, if I pull this thread, can we see y is fluctuating? So it will fluctuate and it will come to still after some time. What is second variable? One y is dependent upon, if I pull it, y is dependent upon x. Where we are, so if left side I consider this is origin, then if I move, then x grows. So y is dependent upon how much x, what is the condition of x. But if I pull it and leave it, it vibrates. Vibrate more, then slowly, okay. So probably because of, so I consider infinite vibration. So it keep vibrating. Now, what is second independent variable? Time. So this is multivariable equation. Now the if I pull it and leave it, then y is dependent upon x. So what I would consider now, or if I do like this, okay, I pull like this, okay. Suppose that y, okay, it's a rubber band. So y is like this. If I pull it and leave it, y would go like this. Okay. So if that is the situation, then y is, so y, when x is growing at the center, y is maximum. When x is growing afterward, y is going down. That is one dependency of the y. Second thing is y is coming to a level, then it is going to 0, then going to minus y, coming to a level, then again going up. So another independent variable is time. So y, the height of the y is changing because we are changing the x. If x is at the middle, y is maximum. But it is variation of the time also. Even when x is at the center, so even when we are here and if I leave it, then it vibrates. So even at we are at the center and expectation is y is maximum, but it is not the case because it is varying upon the time also. So y equal to f x t. This is knowingly unknowingly, this is two variables here. This is multivariate. Z equal to f x y, not required. F x t. So y equal to f x t, and y is varying when x is varying, where y is maximum when x is half the way, and when x is half the way, at that point also y is varying when time is changing. So when x is changing, y is varying, and when x is fixed, then y is again varying based upon the time. So when time is fixed, so if I say like this, so at a particular moment, y is varying only depend upon x. Now if I see only at the center, when x is fixed, okay, so when x is fixed, then y varies based upon the time. So this is typical case of multivariable calculus. Now suppose that my equation is c is a constant, and or I can say c1 sine c2x sine c3t. So generally what we deduce equation for this kind of harmonium or a pendulum kind of scenario. Then based upon the x, so if x varies, then because it will not take the what we are thinking, it will take kind of sinusoidal. So if so, I can consider a case like C1 constant sine C2x sine C3t. So this can be a general equation for y. So y equal to C1 sine C2x sine C3t, where x is in meter and t is in second. Now question arises at time equal to 1 second. Now question arises, what is partial differentiation? So now we came under same tree. What is partial differentiation? So partial differentiation is if time is, so if I want to calculate partial differentiation of C1 sine C2x sine C3t, then I have to differentiate keeping t as constant and then x as variable, and that will become dy by dx, and dy by dt will be keeping x as constant and t as variable. Now if I keep t as a constant, okay, so c1 sine c2x, so with the chain rule, so it will come c1 into c2 cos c2x sine c3t. So this is dy by dx. Now at any time, so consider time equal to 1. If time is 1, then it will become sine C3. Sine C3t was there. So sine C3 and sine cos C2, equation is C1 sine C2x sine C3t. Now at any moment, now if I differentiate dy by dx, keeping uh, t as constant, it will become C1 into C2 cos C2x sine C3t. If that is the case at any point of a time when t equal to 1, at that time, if t equal to 1, then it would be at some position. I won't say it is at maximum. It would be at some position. At that some position, okay, now it will vary. If x is 0, then y should be 0. X is something, okay, so if x is something, then y is something. When x is middle, y is at something. Then if x is like this. So at time t equal to 1, what is the slope of y if I make a change x? So x, if I change 1 unit, then how much y would vary at any point of the x when time is 1. So C1 into C2 cos C2x sine C3, because t is 1. If that is the situation, now I can take any x. So if I take 0.2, okay, I believe it is 0.2 anywhere. So C1 into C2 cos 0.2, 0.2. So C1 into C2 cos C2 0.2 sine C3. Okay, if I put some a realistic variable, okay, then it will typically it will come as 0.002 meter. Okay, that's it. Means at 0.2, at 0.2 at 0.2 from origin, when time is 1 second, at that location, for 1 unit change in x, okay, y would make 0.002 unit unit change. Okay, so y would vary. So y, not the location of y we are talking. We are talking about dy by dx. Means with variation in x, 1 unit variation in x, how much y would vary when time equal to 1. And then equation is C1 C2 cos C2x sine C3t. So t is 1. So C1 C2 cos C2x sine C3. So for some realistic data, if I calculate, it will come to like 0.002 meter. So with 1 unit change in x, when x is 0.2, y would change 0.002 meter. So this is dy by dx partial derivative of partial derivative with respect to x when t is constant. Okay, now when x is constant, so I can take x as 0.2, 0.2 at that point. So when we are at 0.2, now x is constant. Here only I have to talk. So at that moment, if I see, so this is also a sine wave. At that moment, okay, what is the variation in y with respect to change in variation in t? So if t changes 1 second, if there is a variation of 1 second at t at x, okay, so if at x equal to 0.2 location, if there is variation in the time 1 second, how much y would vary? Okay. Now, if I do for dy equal to c1 sine c2 x sine c3 t, then it will come as c1 c3 sine c2 x cos c3 t. Now x is 0.2, that is fixed I want. Now with the variation of t, I have dy by dt. So dy by dt is c1 sine c2 x, so x is 0.2 cos C1 into C3 dy by dt is C1 into C3 sin C2x. So x is 0.2 cos C3t. So cos C3t is the variation. Now at any t, we can calculate that how y would vary as per the t if t varies 1 second. So how much would be y vary when x equal to 0.2? So it will come as C1 C3 sine 0.2 into C2 cos C3t. So if I keep it t equal to 1 and with realistic data around 6 meter per second, it varies. So when x equal to 0.2 at this location, y varies with respect to t value, and if t is 1, then generally 6 meter per second is the variation. Okay, so what we calculated now, that multivariable case, what is the fxt? So fxt, we placed the hypothetical equation c1 sin c2x sin c3t. If that is the fxy, then what is dy by dx partial derivation when t is constant? What is dy by dt, okay, when x is constant? So initial phase we kept t as 1 per second. At the moment when t is 1 second, how much x would vary with 1 unit change in x, how much y would vary. Now we made uh, x as constant, so dy by dt with 1 unit, 1 second change in t, okay, it can be 1 second, 1 millisecond. We are taking 1 unit as 1 second. How much 1 second change in t would change the y, okay, and that I have to, so it will come as a function of t that I have to calculate as per the t. If it is 1 second, anyway x I have taken as 0.2 meter. Typically it will come as 6 meter per second for any realistic case. Now, what is the sign? So, okay, so x is varying this side positively. So x is varying this side positively. At 1 second, okay, time grows in second by second. At 1 fixed second, if dy by dx is positive, means positive at 0.2, means at 0.2 y is going up. Now dy by dt, okay, at 0.2 when time is 1 second, when time is varying, and if it comes as 6 meter per second, then again y is going up. So because at the variation, for the variation of time, y is going up and down. If it is a negative, then y reach the maximum, then it is coming down till it reaches minimum. Full layer it will be negative. Even though y is negative, but if it is going up, then dy by dt is positive. Dy by dx is positive with growing x, y is growing at that moment of the time, and then we can get at that moment of the x. Okay, so this is multivariable case, and then in the multivariable case, this is a scenario with partial derivative. So not necessarily that a 2D multivariable case will be x and y value. What are the independent variables on which it depends? So there are two independent variables. This is a multivariable. This can be multivariable case in kind of many variables. Okay, 2 I have shown, it can be n also. Keeping, so if it is n, so if I want to calculate partial derivative in each, I would say a component, then 1 I have to make it vary, and n minus 1 components I have to keep it constant. Okay, so if it is a x, y, and t, z equal to fxy, z equal to fxy t, then dz by dx equal to differentiation of x fxy t when y and t are constant. So dz by dy when x and t are constant, dz by dt when x and y are constant. So this is a scenario of partial derivative, and as promised we'll see it is in vector also, then cross vector dot product, and these are the real scenarios. So I believe that guitar uh, is enjoyable. It makes sound. See humming sound it makes.